Hello everyone, welcome to this lesson. We're going to solve several questions on probability. Let's begin. Question number 1. Ken, Tom and Peter compete to hit the bullseye in a game of dart. The probabilities of each hitting the bullseye are Ken, 2/5, Tom, 1/4, and Peter, 3/7, respectively. Part A of the question, use the tree diagram to show the possible outcomes. Part B of the question, calculate the probability that part 1, all the three hit the target. Part 2, only one hit the target. And part 3, 2 hit the target. So those are the questions. So let's go directly to the first question, where you're supposed to use the tree diagram to show the possible outcomes. There are three people here. There is Ken, there is Tom, and Peter. So let's go to the tree diagram. So this is how you draw the tree diagram. So we start with Ken. Right here. So there is Ken. So the probability of hitting, not hitting. Then there is the other branch where you have Tom. Hitting, not hitting. Hitting, not hitting. And there is the last person here is Peter. So there is probability of hitting, not hitting, hitting, not hitting, hitting, not hitting, hitting, not hitting the target. Now, having those three branches for the three people, now let's go to the probability. Remember, the probability of Ken hitting the target is 2/5. So this is 2/5. So probability of not hitting the target is 3/5. Tom, the probability of hitting the target is 1/4. So not hitting the target is 3/4. So hitting 1/4, hitting 3/4. Probability of Peter hitting the target is 3/7. So not hitting the target is 4/7. So 3/7, 4/7. So 3/7, 4/7. 3/7, 4/7. Now, having done that, it is good now to get these probabilities like this. So the first one, the second, this one. So this is all the three hitting. Hit, hit, not hit. Hit, hit, not hit. There is hit, not hit, and hit. There is a hit, not hit, not hit. This branch is a hit. No, this is not hit. Then hit, hit, and there is a hit, not hit. Not hit. So those are the probabilities. Those are the three probabilities. So that is the tree diagram. So let's continue to the other part of the question. So the other part of the question is required to calculate the probability that all the three hit the target. The probability that all the three hit the target. So let's do that. So probability of all the three. So probability all the three hit target. So this is, we are going to obtain this from the tree diagram, and this is the branch that you're going to use. This is where hit. So that is a probability of all the three hit the target. So we're going to take this figure, we're going 2/5. So this is how we pick it. So we multiply, that is 2/5, multiply by 1/4, multiply by 3/7. So that is what will give the probability of all the three hit the target. So this will be probably this 2/5 multiplied by 1/4 multiplied by 3/7, and this gives 6 divided by 140, which gives 3/70. Then we go to the next one. The next one is the probability that one hits the target. The probability that one hits the target. So this is why we're going to obtain this, the probability that one hits the target, from the tree diagram. We're going to look for instances where only one of these people hits the target and two fails, like this one. This one is hitting, two are missing. Then here two are missing and one is hitting. This one also. So those are the instances. We are looking for instances where only one hits the target. So here two misses, one hits the second one. So these are the ones that I have highlighted there are the ones that represent the probability that only one hits the target. So therefore this will be given by the probability, this is only one hit, is given by the probability of hit, not hit, not hit, or the probability of not hit, hit, not hit, or probability of not hit, not hit, and hit. So these are the instances that I have highlighted here, the three of them, where you have only one hitting the target and two missing. So taking the probabilities, this is what you have: 2/5 multiplied by 3/4 multiplied by 4/7, or in probability means addition, and in probability is multiplication. So the second one is 3/5 times 1/4 times 4/7 plus this is plus 3/5 times 3 over 4 times 3 over 7. So those are the probabilities. Now what you're going to do is to multiply them. When you multiply these, you get 24 out of 140 plus 12 out of 140 plus 27 out of 140. So adding these, everything gives us 63 divided by 140, and when you simplify these, gives 9 divided by 20. So that is how you're supposed to work out that part. Probability that only one hits the target. Let's go to the next. Probability that two hit the target. Two hit the target. Probability that two hit the target. Let's go to the diagram and highlight instances where only two will hit the target. So 2 will hit the target and 1 will miss. So this is one, this is another one, and then probably the 2 hits the target, and this one is another one. So those are the 3 instances where only 2 hit the target. So let us indicate them here. Now putting down. So probability that only 2 hit the target will be given by the probability hit not, hit not, or probability of hit not and hit, or probability of hit not and then hit. So those are the instances that you have highlighted where only 2 will hit the target and 1 will miss. So those are the instances we have highlighted there. So let's go to now multiplying them out and then we finish. So yeah, the probability, the first one will be 2 over 5 multiplied by 1 over 4 multiplied by 4 over 7 plus 2 over 5 multiplied by 3 over 4 multiplied by 3 over 7 plus 3 over 5 multiplied by 1 over 4 times 3 over 7. So working out these, laying these on out, get 8 over 140 plus 18 plus this is 9 over 140. So when you add these, you get 35 over 140, and simplifying this, it gives a quarter. So that represents now the probability that 2 will hit the target. So that is how you require to work out that question. So we began by the tree diagram, sketching the tree diagram. Then from there, that is where we obtain all the other solutions. Question number 2. The probability that our school will host the soccer and rugby tournament this year is 0.8. If we host, the probability of winning soccer is 0.7. If we don't host, the probability of winning soccer is 0.4. If we win soccer, the probability of winning rugby is 0.8. Otherwise, if we lose, the probability of winning rugby is 0.3. Question part A. Draw a tree diagram to represent this information. B. Use the tree diagram to find the probability that we lose both games. Part 2. The probability that we will win only one game. And 3 is the probability that we will host and lose both games. Part 4, the probability that we win at least one game if we host. So those are the questions. So let's go to the first part of the question, which is drawing a tree diagram to represent this information. So we need to draw this tree diagram, and before we draw this tree diagram, we need to decide on the initials you're going to use, the letters to indicate the probabilities. So there is the probability of hosting soccer. We'll host soccer and rugby tournament. Okay, so what we are going to do, we will have letter H. We shall have letter H. This will show the probability of hosting. Then winning soccer, we are going to use WS. This will represent the probability of winning soccer. Then there is lose soccer. We use LS, that is losing soccer. And then we shall use another one for winning rugby, WS. This is WR. This is R. So this is winning rugby. Then losing rugby, LR, losing rugby. So those are the initials you're going to use. So we start with the probability of hosting. So let's draw the tree diagram now. So this is how you're going to draw it. So that is the probability of hosting, not hosting. So this is 0.8. So the other one will be 0.2. Hosting and winning soccer. So this is winning soccer. This is losing soccer. This is winning soccer. Winning soccer, losing soccer. And this is given a 0.7. This will be 0.3. This will be 0.4. 0.6. Then we have if win soccer, the probability of winning rugby. So we shall have other branches here. So winning rugby, losing rugby, winning rugby, losing rugby, winning rugby, losing rugby, winning rugby, losing rugby. So after doing that, now we can indicate these probabilities for easier working. So this is hosting, then winning soccer, winning rugby. Now hosting, winning soccer, losing rugby. This is hosting, losing soccer, winning rugby. Still hosting, losing soccer, losing rugby. Not hosting, winning soccer, winning rugby. Then there is not hosting, winning soccer, losing rugby. Not hosting, losing soccer, winning rugby. Not hosting, losing soccer, losing rugby. So that is the tree diagram, which will be very helpful. Let us indicate now all these probabilities. So this one you have 0.8, this you have 0.2, so this is 0.3, that one will be 0.7, 0.8, 0.2, 0.3, 0.7. So that is now a complete tree diagram showing all these probabilities. So after having the tree diagram, this is what you're going to use to solve all these questions. So let's go to the first question. B part 1, probability that we lose both games. Probability that we lose both games. So that is the first thing we need to get, probability that we lose both games. So let's calculate that. Now, the probability of losing both games, we're going to obtain it here. And I'll highlight instances where two games will be lost. So hosting and losing both games. Hosting and losing both games. This will be the first instance. Then not hosting and losing both games. So those are the instances where two games will be lost. Hosting and losing soccer and losing rugby. Not hosting, losing soccer, losing rugby. So now we can write this. So probability of losing both games will be indicated by probability of hosting and losing soccer, losing rugby, or the probability of not hosting, losing soccer, losing rugby. So obtaining these from the branches, the first one, hosting, losing soccer and losing rugby, will be 0.8. We pick that branch, 0.8, and this is how we pick it. So it will be 0.8. Then that is hosting, then losing soccer times 0.3, then losing rugby 0.7. So that is how we pick it. That is how we pick that branch. So 0.8 multiplied by 0.3 multiplied by 0.7. So or in probability means addition, not hosting and losing both. So not hosting and losing both. So not hosting is there, losing soccer and losing rugby. So that is how we pick it. So this will be given by 0.2. We use a different pen here. 0.2 multiplied by 0.6 multiplied by 0.7. So working out this gives 0.168 plus multiply these, you get 0.084, and upon addition this will give 0.252. You can leave it like that, or in form of fraction. This will be 63 divided by 250. So that is simply how you're supposed to get the probability that we lose both games. The next one is the probability that we win only one game. The probability that we win only one game. So we go to the tree diagram. Where do we win one game? We win one game here. So hosting, we win one, we lose one. So winning soccer, like here, hosting, and winning soccer, losing rugby, we win one game. Then the other one is here, hosting, losing soccer, winning rugby, still we win one game. Then when we're not hosting, there is this hosting, not hosting, winning soccer, losing rugby. Then this one is another one, not hosting, losing soccer, and winning rugby. So the ones that I've highlighted in yellow are instances where only one game is won. We win only one game and lose the other. So hosting, winning soccer, this one. So hosting, winning soccer, losing rugby. Hosting, losing soccer, winning rugby. Not hosting, winning soccer, losing rugby. Not hosting, losing soccer, winning rugby. So those are the instances. So this will be given by probability of hosting the first one, winning soccer, losing rugby, or the probability of hosting, losing soccer, winning rugby, or not hosting, winning soccer, losing rugby, or probability of not hosting, losing soccer, winning rugby. So those are the four instances. So picking the branches, picking the probability from the branches. Now we know how we pick the probabilities following the branches. And this is what we have. We have 0.8 multiplied by 0.7 multiplied by 0.2 plus 0.8 times 0.3 times 0.3 plus 0.2 times 0.4 times 0.2, or last one 0.2 multiplied by 0.6. We have let's put this here. So the last one is 0.2 times 0.6 times 0.3. So that is how you obtain, and you obtain these probabilities following these branches, like the way we have demonstrated in the first part of the question. So now adding these, multiplying and adding, you get the first one 0.112 plus 0.072 plus 0.016 plus 0.036. and this gives 0.236, or in fraction form be 59/250. So that is how you're supposed to obtain those probabilities. That is when we win only one game. Now we go to the next part. The next one is the probability that we will host and lose both games. The probability that we will host and lose both games. The probability that we will host and lose both games. So when you go to the tree diagram, let us look at the probability that we host and lose both games. And here it is. Here it is. The probability that we host and lose both games. So hosting, losing soccer, losing rugby. Here it is. This one. Probability of hosting, losing soccer, losing rugby. So this will be given by the probability of hosting, losing soccer, losing rugby. That is when we host and lose two games. So this will be given by picking the probability. It is just, we had already even done this, 0.8 times 0.3 times 0.7. So this will be given by 0.8 multiplied by 0.3 multiplied by 0.7. And this, we had multiplied this 0.168, or you can leave it as in fraction form, which is 21/125. So that is how you're supposed to do that part. Then the last one, the probability that we win at least one game if we host. So hosting and winning at least one game. So the first thing, at least one game means we win one game or we win both games. That is what we mean by at least one game. So we win at least one or both games. So this will be given by the probability of, and if we hosting, winning soccer, losing rugby, or probability of hosting, or this one we can have, let me start with first one, winning soccer, winning rugby. That is when we win both games. Then hosting, winning soccer, then losing rugby, or a probability of hosting, losing soccer, and winning rugby. So this represents the probability that at least one game is won or two. Like here, two games are won. Here, winning soccer. Here, winning rugby. So those are the three instances. So picking them from the tree diagram, those branches, this is what you get, and this is where you pick those probabilities. You pick them there. So you get the first one, 0.8 times 0.7 times 0.8, plus the second one is 0.8 times 0.7 times 0.2, plus 0.8 times 0.3 times 0.3. Adding this, you get 0.448 plus 0.112 plus 0.072, and this gives 0.632. So that is simply how you're supposed to work out that question.